So in this presentation I will ask the question whether there is a need for mortality forecasts, not just actual mortality data, in order to appraise the effect of COVID-19. These slides were prepared on the 10th of March 2021. So as already stated, the question is it possible to assess the impact of COVID-19 and hence government's responses on either a nation or state level? In order to do this, I'll use data from England and Wales as it's readily available from the Office of National Statistics. I will end up suggesting that without a baseline forecast, the data itself is to some extent meaningless, difficult to interpret, because any conclusion will depend on a forecast as well as reality. You need something to compare the measured data to. So this is the data from the Office for National Statistics, and it's calculated on a calendar year basis, so it looks at the number of deaths running from the 1st of January to the 31st of December of a given year. Two statistics are given: the crude mortality and the age standardised mortality. The crude mortality is the number of deaths divided by the population, whereas the age standardised mortality converts to a European standard population distribution. And what we can see in the year 2020 is that mortality was approximately 1%, 1,000 deaths per 100,000, and it hadn't been that high since 2003. And similarly, if one looks at the age standardised variable, the mortality was again about 1% in 2020, and it had not been 1% since 2010, 2009, 2008. Looking more closely though, the mortality does look like there was a period of decline, followed by a period in which mortality is again increasing, except for a possibility of a downward fluctuation in the year 2019, the year before COVID first hit. So if we plot crude mortality, it makes that more clear. We can see there's a downward mortality trend and then a possible upward mortality trend, which looks fairly real, may not be real, but looks fairly real, and the possibility of a downward fluctuation in the year 2019, and obviously an upward fluctuation in the year 2020 when COVID hit. It is though difficult to actually draw any conclusion from that behaviour. Here we have two lines, a black line and a red line, and if we say each of those demonstrate the trend in mortality, we can see that each line seems to go through the data quite well. Then the red line has a small downward fluctuation in 2019 and then a big fluctuation upwards in 2020, affected by COVID-19. Whereas if we use the black line to demonstrate a trend behaviour, we see that it looks like 2019 is quite exceptionally low in mortality, and 2020 is an upward trend, plus perhaps the result of an underlying vulnerable population that didn't die in 2019. The only difference between these two fits of the data is which points they include. The red line is exclusive of the COVID year and the black line is inclusive of the COVID year. But to draw conclusions, one has to decide on which forecast mortality one should use. So at the moment we can conclude that yes, 2020 was the highest mortality for more than a decade and approaching 2 decades. However, this might not be unusual, because fluctuations do occur. In a report by Public Health England in 2000 and at the end of 2018, the observation was made that the provisional age standardized mortality in that case for the first quarter of 2018, January to March 2018, was the highest since the first quarter of 2009. So it is possible for mortalities to change quite dramatically. Our main question, though, is what is the role of COVID-19 in the mortality? Is it that COVID-19 is something dramatically different and that has increased mortality excessively, or is it that COVID-19 is a slightly harder virus than people are used to and it has highlighted an underlying health problem? So in order to show this problem more clearly, I'm not going to use calendar year data, I'm going to use mid-year data. That is, I'm going to calculate from the 1st of July on a given year to the 30th of June on the following year in order to calculate a mid-year to mid-year mortality. And for simplicity, take the population at the beginning of that period. So look at the number of deaths over this period and divide by the population at the beginning. The reason for doing this is that mortality in England and Wales, the data we're going to use, shows quite a strong seasonal behaviour. So for example, if we look at the year 1997 began with daily mortality over 2,500 per day, which dropped down in the summer months to below 1,500 per day and then rose again towards the end of 1997. If we compare it with 1998 starts above 1,500 per day, but it is below 2,000 deaths per day, so much lower than the beginning of 1997. However, the end of 1998 achieves high values of deaths per day, over 2,500 deaths per day. So these 2 years end up looking quite similar because they are essentially reflections of each other. However, the reality is hidden then of what's actually happened. The period mid-97 to mid-98 had a less extreme seasonal mortality behaviour than, say, the period mid-98 to mid-99. So for fair comparison, we should use seasonal data. So in this case, mid-year to mid-year. That may vary depending on nation or state considered. And it's also arguable that this is more useful data as it enables one to consider forecasting capacity that might be required. If there is a particular season in which for some reason the number of vulnerable people, vulnerable to things such as extreme weather conditions, seasonal viruses, short days, festive shocks, things that might cause higher mortality, for some reason these are lower, then there's a vulnerable population that carries through to the next period, which may have high impact. So in order to do this, I need mid-year to mid-year data, so I've had to calculate this myself. But again, it's accessible from the Office for National Statistics, at least for England and Wales. There's sets of data for population estimates and there's data for daily deaths. Unfortunately, the daily deaths only run up to 2018, but to calculate the years 2019, 2020, there are weekly provisional figures for deaths registered, and that's probably good enough. So carrying out that calculation and plotting the data, we can see, as expected, there's fluctuations from year to year, and again, as we might expect, from July 2019 to the end of June 2020, there is quite a high mortality, approaching 1% here, given as deaths per million. So 1% is 10,000 per million, and it does look like there is some potential upward trend, that the year July 2018 to June 2019 is below trend, and the first COVID wave or first COVID season is above trend, which means we need a trend to compare with. So I'm going to put in a trend, a mortality forecast, and we should note that mortality forecasts are not made in the way above. In the simple way I'm going to show, there are some quite complex methods to calculate mortality forecasts, and one can look those up in the literature. So I'm going to use a simple moving average to calculate the trend mortality, and I'm going to average over 5 years, and then from a given average year I can forecast forward by saying what's the trend in that year plus what is the trend rate in the previous year multiplied by the number of years forward, essentially a straight line forecast. So here's the example of that. The black line shows this centered moving average over 5 years. So for example, 2012 to 2013, the black line is calculated by this year plus this year plus this year plus this year plus this year divided by 5, and we can see that expected value, that trend value, is below the value that was actually observed. The year 2013 to 2014, the trend value is calculated by this year plus this year plus this year plus this year plus this year divided by 5, and that year is particularly below trend. The reason I can draw the black line in these first 2 years is I actually have data over here as well. We only run up to 2016-2017 and call this as an excluded forecast because we are not using the years in which COVID occurred, 1920 and 2021. We assume that those years are unusual. So if we don't use those years to make a forecast, the last year we can use is 1819, and 5 years are 1, 2, 3, 4, 5, and this is the last trend that we can calculate from a moving average forecast. But we can then project forward by taking this linear line here and just extending it out linearly, and one can argue that whether that's valid and for how many years it's valid. But what we see if we do that is that 2018-19 is below trend, 2019-2020 is above trend, but this is a few percent below, and this is a little more than a few percent above. And at the moment we can't say anything about 2020 to 2021 because we need to get to the end of June to make a calculation. On the other hand, we can make an estimation. So to make that estimation, we can again go to Office for National Statistics data, and we have the deaths registered per week ending up to 26th of February 2021, and these are updated every week. And what we can see is that in the mid to the back end of January, deaths per week were high as the second COVID wave or the second season of COVID hit, but these deaths per week are now heading down and they are approaching values that are typical for this time of year, and it's considered that these values may indeed go back down. So if we assume March, April, May and June return to relatively normal values of deaths per year, we can make an deaths per year, deaths per week, we can make an estimate of mortality for 2020 to 2021. Of course, these values may not go down, they may stay at around 13,000 because there have been various interactions which have involved removal of treatment, isolation of people, etc., which can make people more vulnerable to illnesses. But let's hope that mortality returns to more normal values. If we make that assumption, we can put in an estimate for 2020 to 2021, and this shows clearly that mortality oscillates around the forecast value, sometimes approaching a 5% oscillation, as does 2018-2019. It does look unusually low, so there may be some vulnerable population carried forward into the following year, but nevertheless the first COVID season led to mortality that year over 7% greater than might be expected if this forecast is correct, and if deaths per week return to fairly typical values, the period 2020-2021 would still have a mortality 4% greater than might be expected. But it has to be stressed, this depends on the validity of the forecast, and we have excluded the COVID years from the forecast on the basis that these are exceptional years. Another viewpoint may argue that these are not exceptional years and they should be included in the forecast. If we now include those in the forecast, these 2 years become available, so we can do a moving average including the forecast, and that means we can calculate a moving average up to 2018-2019. This year is calculated for a forecast shown in orange by this year plus this year plus this year plus this year plus this year divided by 5, and then again we can take this part of the moving average and project forward for 2 years linearly. Under those circumstances, obviously the numbers down here remain the same, but we can see a difference based upon the 2 forecasts, not the actual data. In the first forecast, it looks like 2018 to 2019 was quite a low year in mortality, followed by, in the first wave of COVID and the second wave in COVID, quite high fluctuations above the expected value, even given a higher than normal vulnerable population carried forward. However, if the COVID years are considered fairly typical, except that COVID is taking a close examination of the underlying health of the population, then what we see is that for some reason the year 2018-2019 was unusually very low in mortality, and the year of the first season of COVID could be explained by a large vulnerable population carried forward and then achieving a more normal closer to the forecast value in the year 2020 to 2021. Stressing we don't know this yet because we are assuming what will happen in March, April, May and June. If it were the case that in March, April, May and June the number of deaths stayed at around 13,000 per week rather than reducing to more typical numbers, then it would actually mean that the mortality would be above 1% and approaching 1.1%. Is it possible to make a conclusion of how dramatic the effect of COVID-19 has been on English and Welsh mortality? Well, if we were comparing the actual data with the exclusive forecast we made, which was a straight line extrapolation of averages based on years that did not include COVID, then it does look like COVID has had an exceptionally poor effect on mortality. Initially 2018 and 2019 was below expected, below trend, 4.5%, so there is a population of vulnerable people carried forward into the following years, and this will explain part of the increase in mortality in 2019 and 2020, but only part of it. It remains a high value, and 2020 to 2021 also remains high, so we have a very high year followed by a high year, and it looks like COVID has had a dramatic effect on mortality. However, if we think that the COVID years shouldn't be treated as exceptional years and included in a time series average so that we have a different trend line, and we call this the inclusive forecast, then what looks exceptional is actually 2018 and 2019, and it's exceptionally low, so 6.3% below trend, leaving a large vulnerable population to carry forward into the following years. And then given that large vulnerable population, what we have seen in 2019-20 and what we think we will see in 2020-2021, assuming March, April, May and June stay at typical values of deaths per week, these numbers would not be considered that unusual, which leads one to say nations and states should provide justified forecasts of their mortality rate alongside real data, so that we can start to consider whether the issue is that COVID itself has been a very exceptional virus leading to large increases in mortality, or whether COVID has been a harsh virus, but not exceptionally harsh, but has looked at the underlying health and the underlying health systems of countries much more closely than previous viruses have.